All right, environmental science, this is your video for Unit 7, Part 3. This goes over the control of these air pollutants that we've talked about in Parts 1 and Part 2. So, first thing you should do to improve air quality is reduce the amount of air pollutants going in the first place. So, that's always the first course of action, is eliminate pollutants getting into the air in the first place. And remember, most of our pollution comes from this, NOx, plus VOCs, plus sunlight, makes ozone, because ozone is our secondary pollutant that we're most worried about as far as pollution or smog goes. Okay, so if we can lower the amount of NOx getting into the air somehow, or lower the amount of VOCs getting in the air somehow, obviously we can't eliminate the amount of sunlight getting into the air, but if we can eliminate one or both of these things, then the ozone levels would drop as well. Okay, so most control of smog, at least, is centered around that one thing. Okay, we can also try and reduce the amount of sulfuric acid. So if you reduce the amount of SOx getting into the atmosphere, that'll reduce the amount of acid rain or sulfuric acid getting in the air and stuff like that. Okay, now if you can't reduce that stuff, one of the ways to reduce it is to try and control it in the first place. So control involves remove pollutants or change the pollutants into less harmful chemicals. So if we can remove the pollutants or change the pollutants into less harmful chemicals, then that's a good thing. Probably one of the best examples of that is CO2 or carbon monoxide, changing it to carbon dioxide. So in a catalytic converter, which we're going to talk about on the back of these notes, that can take some CO, mix it with oxygen to produce CO2. So carbon monoxide causes death potentially, but from carbon monoxide poisoning, but carbon dioxide is not harmful to humans when we breathe it in or breathe it out, because that's what we do every time we take a breath out. CO2 is a greenhouse gas, so that leads to other problems too, but CO2 is not considered a toxic air pollutant. Okay. Another example of that, of trying to control it, you don't really see this in Texas, but this was one of the things that actually surprised me in Texas. In California, where I grew up, the gasoline stations have these special nozzles that's basically a boot that tries to collect the gasoline vapor when you pump gas in your car. They're not super easy to work with. It takes a little bit of getting used to, because if they don't seal properly, then the gas doesn't pump. But in California, they have these special nozzles. They're called a vapor recovery nozzle. And I've seen them occasionally in Texas, but they're not mandated, which is actually kind of surprising, since we don't meet the clean air standards for ozone. And gasoline is a VOC. If we reduce those volatile organic compounds, or the gasoline getting into the air by evaporation, then we could reduce the ozone as well. So I'm actually surprised that that's not an air pollution measure that we take in Texas to try and do that, but they do it in California. So a vapor recovery nozzle captures the gas vapors, which again is a VOC, so it's capturing the VOCs essentially as well. Okay. All right, there's just a couple pieces of pollution control equipment that I want you to be familiar with. These are we're going to focus on the ones that they ask the most on the AP exam. There are some other ones as well, but we'll just try and keep it somewhat simple for this year. Okay, so this is a mock-up of a coal-burning power plant. Really, the only way you would know that is you got the coal right here. So they pump in air here, just like we did with the energy unit. Remember, we burn the coal to heat up water to produce steam. That steam turns a turbine, which turns a generator, which produces electricity. So this is an example of something that you would see on a coal fired power plant or electric plant. Okay. So what they do is they mix the coal and the limestone, and limestone is calcium carbonate. All right, so this is used in a coal power plant. They mix the coal and limestone, which is calcium sulfate, and that sulfate reacts with the, the calcium reacts with the sulfur that's in the coal to make calcium sulfate. I said that wrong. So the coal mixes with the limestone. The SOx, or the sulfur that's in the coal, mixes with the calcium that's in the limestone to make calcium sulfate. And that's actually something that they can use. So this is called a desulfurization unit. So this takes the SOx from that would otherwise go into the air, mixes with calcium carbonate, and makes calcium sulfate. And if you're sitting in your house right now, if you look at the wall, you're looking at calcium sulfate, because calcium sulfate is used to make wallboard. So they can actually sell it as a valuable product. So that's one way that they can reduce the SOx emissions, or the sulfur coming out of a coal power plant, is to mix that coal with some limestone or calcium carbonate. Okay. And again, that's called a desulfurization unit, is typically what they call it. All right, probably the two most important ones are the ones on the back. Here's a picture of the catalytic converter that I've been talking about in the notes previously. This was put on the cars in the 1970s and has really been the game changer on reducing pollution that comes from cars. So this is called a catalytic converter. It's called a catalytic converter because there's a catalyst. Hopefully you remember or learned in chemistry that a catalyst is something that promotes chemical reactions but doesn't actually get used up. And then the converter part is it's converting it from a more harmful chemical to a less harmful chemical. Okay. So you can kind of see this in here. There's actually two stages. The stage one is the reduction catalyst, and stage two is the oxidation catalyst. Okay. So the hot air comes from the engine. It warms up this mesh of metal that's basically just a mixture of platinum, palladium, and rhodium. So these are made of platinum metal, palladium metal, and rhodium metal. And the different two stages do two different things. So in the reduction catalyst, the NOx that would go into the air that can become part of your pollution gets converted into N2 plus O2, which are natural parts of our atmosphere, because 78% of our atmosphere is N2 and about 20 or 21% is O2. So this will reduce some of the NOx, not all of them, but it does a really good job. So this cuts down the NOx tremendously. And remember, if we can cut down the NOx, then that cuts down the ozone, because NOx plus VOC plus sunlight makes ozone. So if we can reduce the NOx, then we can reduce the ozone. So it's good for our atmosphere. Reducing the NOx also reduces our acid rain due to the formation of nitric acid when NOx mixes with water. So it does a couple different things. Okay. So that's the reduction catalyst. In an oxidation catalyst, you're adding oxygen. So for the oxidation catalyst, that converts carbon monoxide into actually, let's just do that, carbon dioxide. So it mixes with oxygen and promotes the formation of CO2. And then the other thing that happens here is gasoline, which is a hydrocarbon. So most gasoline is C8H18. that can convert that into, with mixing with oxygen again, to CO2 plus H2O. So it can reduce some of the unburned gasoline as well. And again, gasoline is a VOC, so if you reduce the VOCs, then you reduce the ozone as well. So a couple different stages here to reduce the formation of ozone. Now again, it doesn't capture all the NOx, it doesn't get rid of 100% of the gas vapors, but it probably gets rid of at least 90–95% of it. Another thing to know is the catalytic converter works best when it's hot. So when those platinum, palladium, rhodium metals do a better job when it's hot. That's why the catalytic converter you usually find fairly close to the engine. The other super important thing to know about that is because when you first start your car, for instance, in the morning after sitting all night, this metal is cold, so it's at room temperature, right? So it takes a while for that hot air flowing through here to heat this metal up so that these catalytic converter, catalytic reactions start to occur. So it's important to know that most pollutants from cars are emitted in the first couple of minutes. So it may start out only maybe 50% efficient, or maybe not even that, but it gets up to 90, 95, 98% efficient at removing these otherwise toxic pollutants or hazardous air pollutants once this thing warms up. Okay, that's why they tell you if you want to be more environmentally friendly, you should do all your errands at one time. So rather than go to the grocery store in the morning and then come back home and then maybe go get a haircut in the afternoon and come back home. If you do all of these things at once, go to the grocery store, then you go to the hair salon, and then you come back home, this catalytic converter stays hot or warm for a longer period of time. So rather than warm it up and then have it get cold again and then warm it up and get cold again, it's more efficient or works better if you do all your errands at once. Okay. All right, other one to know, and this is one that you probably haven't heard of or probably won't see in your real life situation, but this is the one that's used the most in industry, and it's called an electrostatic precipitator. So this is called an electrostatic precipitator. This is best for removing SOx and particulate matter. So what it shows here is you have an airstream coming through here. These little particles or particulate matter, you can put them through alternately charged grids. So you have a negatively charged grid that it goes through that imparts a negative charge onto them. And then since a positive gets attracted by a negative or a negative gets attracted to a positive, when these particles are charged with negative, they go to these positively charged plates and they stick here and they come out of the air. So some of these particles will make it through, but this works about 90% efficient, usually maybe a little bit higher than that in some cases. So this particle, for instance, this one right here, rather than go through the airstream and out into the atmosphere, it'll get attracted to this plate and it'll stick to this plate. And then every once in a while they'll shut this off. They may shake these plates to remove all this stuff, and then that would go to like a hazardous waste landfill. So that's what they're showing here is when they shake these plates, those particles get trapped here, and then they can take that and put it in a landfill or something like that. Okay, so again, that's called an electrostatic. It's electrostatic because you're putting a charge on these, a negative and a positive charge, so that they attract each other. And precipitator just means you're taking it out of the air and making it a solid instead. So it's a good job of doing that. This is most commonly found in industry. So the company I used to work for, we had quite a few of these electrostatic precipitators in different processes. And again, that's to remove these particulate matter. And you can also use it to remove some SOx emissions and stuff like that too. Okay. All right, for some reason the AP, when they redid this in Unit 7, it's mostly about air pollution, but they also stuck noise pollution in there as well. So just a little note about noise pollution. Any construction or loud noises can scare animals away or scare birds away. It can also stress the animals. So noise pollution, again, is any loud noise. A lot of times you can say it's due to construction or something like that. That can scare birds and animals away from a particular region or habitat and then disrupt their lives. Another good example of that is for noise pollution is boats, their propellers, or for instance, like submarines and stuff that use sonic waves. Those have been shown to affect whales or dolphins or other animals that communicate through sound waves. Those boat propellers underneath the water, or like I said, a submarine or something like that that uses or emits sonic waves, can affect whales. That would be another considered another source of noise pollution just underneath the water. Okay. All right, again, if you have any questions, there are other videos that you can look up, or you can email me any questions on this or text me questions on this as well.